So what are complex numbers? That's what I want to talk about today, and I'm going to start by looking at this example where I have x squared equals 16. Now, I can think of two things quickly that when I multiply them together, I get positive 16, right? And that's what this question is asking for. What numbers do that? Well, I know that if I plug in 4 times 4 is 16, so that works. But I also know that if I plug in -4 times -4 gives me 16, right? So here I have two solutions to this equation. These equations are called quadratic equations that we'll talk about later. All right, but what about this example? X squared equals -16. So now I'm charged with finding a number that when I multiply it by itself, I get -16. And you'll think about it for a little bit. It can't be negative because a negative times a negative becomes positive. It can't be positive either because positive times positive is positive. So it looks like there's no solution here. There's no solution. And that is true in some sense. There's no real solution, meaning that there's no real number that satisfies this equation. But we can enter into a different world like this. So we're going to define the imaginary unit to be a new number, a new kind of number that we write as I. And this I stands for the square root of -1. The square root of -1. So that means now with this new number here, I squared becomes -1, right? Because the square root of -1 times the square root of -1 becomes square root of -1 squared, which is -1. With the imaginary unit, we now have a number that can multiply by itself and get a negative value. All right, and so I'm going to show you some examples of this. And from this, we can find complex numbers. All right, in example part A, we have the square root of -16. Okay, so now I'm thinking of two things that multiply to give me -16. All right, so the way I think about this is I know 4 times 4 gives me 16. So I'm going to break this down like this. -1 times 4, right? Okay, so since the 4 shows up twice under the radical, I can take that out. So I have a 4 times the square root of -1, and wait a minute. The square root of -1 is that imaginary unit, I. So there it is. The square root of -16 is actually 4i. So now when I think back to the original equation, where I had something like this, I now can think of some solutions. I know that x can be 4i, and I also know that -4i times itself will also give me -16. Okay, now let's look at part B. We have the square root of -64. It's the same idea. Okay, so I know that 64 is the same as 8 times 8. So that means I can take the 8 out of the radical, and I'm left with a square root of -1, which we know is I. The square root of -64 is 8i. All right, so now when we look at part C, the square root of -50. For -50, I have to think for a minute. Let's think. How does this break down? I can take out the -1. 50 is not a perfect square root by itself, but I know it's 2 times 25, which is 5 times 5. Since the 5 shows up twice in my radical, I can take that out. So I have 5 times -1 times 2 in the square root, okay? But the square root of -1 we know is I. So this number is 5i times the square root of 2. And the square root of 2 doesn't really simplify any more than that. All right, so there is my solution to the square root of -50. All right, now this part D, we're looking at I cubed, and we're trying to figure out, can we simplify that any? Okay, so this is a little bit different than the others, but let's think. I cubed means I times I times I, right? That's what that means. And I also know something about I times I, right? Because I is the square root of -1, so we said that I squared is -1. So I cubed can actually reduce down to something easier. It can reduce down to -I. And there it is. Now that we have an imaginary unit, we can define something called the complex numbers. And so we define a complex number to be a number of the form a plus bi. All right, and here a and b are real numbers. So anything that can be written as a plus bi can be considered a complex number. Okay, so we already saw some of those. 4i is a complex number. Okay, 1 plus I is a complex number. And what about 3? 3 is also a complex number because that's 3 plus 0i. And so even though this may seem like a new world for us, actually everything we've ever dealt with has been in the complex numbers. All the real numbers lie in the complex numbers. Okay, so to show that, we define the set double stroke C like that to be the set of all numbers a plus bi, where a and b are real numbers. Okay, so we could do a Venn diagram like this. Here are my real numbers. Now we have a much broader set that includes the real numbers, but a lot of other things as well, right? So for example, I is not a real number. 3 is, but 3 would also be a complex number. Okay, so you've been dealing with complex numbers for a long time. All right, now I'm going to show you how to do arithmetic with complex numbers. Hopefully it'll make sense. If you have any questions on this, please let me know. I'll be glad to help. And thanks for watching.